All right, welcome to another Noria webinar. We want to give a special thanks to AssetWatch for sponsoring this webinar. And today we're going to be talking about condition monitoring. Now, we're all somewhat familiar with condition monitoring, different technologies, different tools. But today you're going to hear a great story about someone that is actually utilizing condition monitoring and beyond that, real-time condition monitoring to really improve their reliability program. So thank you again for joining in. Just a few things to keep in mind. You can use the chat feature, but the Q&A feature in the window gives us a direct line to your questions. Sometimes the chat doesn't allow us to respond as quickly. So if you can please use the Q&A feature, that would be fantastic. We will be responding to these questions. In fact, we're going to set aside some time towards the end of the webinar to actually answer a few of the questions. We're going to answer as many as we can. If you don't get your question answered, live, we will be, chatting with you and make sure that you do get an answer to whatever you may have. And if for whatever reason there should be a snafu with sound or video, stay with us. We'll get it relaunched or anything else. But, we've been doing these for a little while. We don't anticipate anything going on. But if we do, we'll get it corrected very soon. So with that, let's go ahead and let's talk a little bit about like the benefits, challenges, and limitations with condition monitoring. And condition monitoring as a whole, right? We're looking at how the machine is operating. We're looking at environmental factors. And really the whole underlying goal here is to get some sort of early warning or a detection of something that could be going bad. And there's a couple different ways that we can think about this, right? If you remember the PF curve, right, of as a machine starts to fail, with condition monitoring, we're trying to push up that curve to where we're detecting it when, it is still very, very small, to where maybe we can minimize the impact of a potential machine failure. So this is very much, trying to move from a reactive mode into a predictive mode. Reactive maintenance is, of course, whenever we're doing something after the machine has failed. And reactive maintenance is basically when operations is telling us that the machine's not doing what it's supposed to be doing. At that point, we have a functional failure. So with condition monitoring, ideally, if we are able to detect a fault, because this is what condition monitoring is, we're looking for failure symptoms, we're looking for faults, we're looking for things that are going to lead to problems. If we can detect those early, we can take some sort of corrective action to hopefully minimize any sort of operational impact. Now, some of these detections, or some of the things that we may do, filtration could be one of them. I've seen this many times where we detected a contaminant, right? Water got in, dirt got in. So this triggers some sort of decontamination event. We use a vacuum dehydrator. We use a filter cart. Maybe we change the oil or we add grease, right? We're trying to do something to help minimize that sort of impact. Now, whenever it comes to an actual machine defect, we start to have those conversations. All right, do we continue to let it run? How bad is it, right? So now we're almost in a prognosis and a diagnosis stage. Is it threatening? Is it something that we need to switch from pump A to pump B, right, if we have a redundant system? Or do we need to schedule some downtime here in the coming days, the coming hours, to actually take some sort of corrective action? So this really minimizes the amount of unplanned downtime, or it can really help us with the spares and stock inventory side of things, because if we know something's going bad, we can start making sure that we have the right people, the right tools, the right spare parts to actually correct the issue. So there's a lot of benefits with condition monitoring. Not only is it making sure that the machine's more reliable, but the cost savings associated with the reduction of downtime, the reduction of labor, the reduction of maybe outside contractors coming in, or even just the cost of the failure parts themselves. So there's a lot of cost savings there. And not to mention, think about the safety aspects of this, the environmental aspects of this. OSHA did a study when they were talking about, I think it was 1 out of every 4 hand injuries occurred when a maintenance job was unplanned, meaning that it was a reactive maintenance thing. So, you think about that. The machine goes down. It's only natural that maintenance is saying, well, let's go, let's try to get it, fixed. Let's get it back up and going as quickly as possible. And this is where, you slip off of a wrench, you bash your knuckles. Maybe you're not, thinking about where your hands actually are. They get, pinched or anything. So there are safety aspects to this. And then the environmental aspects. If we had a failure, one of the first things that people do whenever a machine fails is usually drain the oil out of it. Well, if you want to talk about like a carbon footprint associated with lubricants, the actual hydrocarbon lubricant, that has an impact. Plus, that lubricant has to be disposed of. Or let's say that this failure, caused some sort of catastrophic issue and released, a product or a lubricant or something into the environment. This can be, potentially very hazardous. So condition monitoring, not only helping us with our operational budget, our maintenance and repair budget, but also thinking about environmental stewardship too. So, it does have its fingers, a lot of different places. And even with this, right, we still have people that push back on thinking, maybe condition monitoring isn't the best move for us. Maybe we should focus on something else. So what we'll find, or what you tend to find is, getting that buy-in from the staff can be difficult. And I have no doubt, I've known Scott for a while now. He's going to have some great insights to how to get staff buy-in, because it's not always just trying to get somebody to trust technology. It's actually making them understand that, man, this is going to be better for you. It's going to be better for the collective organization. There is a huge benefit, because ultimately, if the staff isn't bought in the direction that we're going, this is doomed to fail. So we have to get buy-in, very quick. And then, sensors are nothing new, right? Sensor technology has been around for a while, and we have a lot of data with operating systems. If we're tracking, power consumption, or if we have other sensors, with condition monitoring, we need to think about how do we integrate some of these systems together. A great idea with this is going to be oil analysis data with vibration data, right? These, to borrow my Forrest Gump reference, they go together like peas and carrots, right? Because they both are great technologies, and both of them will tell you something different about the machine. And it's not that one is better than the other. It's about how do they play well together. So a big consideration whenever we think about condition monitoring is to utilize the toolbox, but to actually make sure that the toolbox is representative of what we need to know from the machine. Because too many times we see these disparate systems out there where we've got great data, but they're so siloed off that we can't take any actionable measures or take big actions and catch things early, because the data isn't being interpreted well. And I think that brings us to our next point, is the data that comes in does have to be interpreted. It does require a certain amount of skill. It requires a certain amount of education. For a lot of people, they will push for certifications within condition monitoring, whether that be lubrication, whether it be vibration, ultrasound, thermography. There's a lot of different certifications. And you need to make sure that you pair the educational component with the hardware component. You got to make sure that people understand what's actually going on, the benefits of it. This helps with the buy-in, but it also helps make sure that the technology is utilized. And ultimately, the technology is fantastic, but there are always limitations to different technologies. Whenever we think about, things that are very sensitive versus very specific, right? Because sensitivity to something that's going on versus specificity, being able to tell you exactly what's going on, or a certain component that is going bad, we have to blend this, right? Because if we want to get more and more specific to monitor for a single thing, right, we may lose some of the ability to look at the machine as a whole, and not all sensors are the same. Depending on how they are mounted, depending on what type of technology they're using, these sensors can have a wide range of different data that they're actually feeding back to us. And whenever we think about condition monitoring, like we talked about, integrating different technologies together, so many people get so focused in on a single technology that they may miss the holistic sphere of condition monitoring, where we can utilize multiple technologies to really know what's going on with our machines. And then obviously, depending on the environment that we're operating in, Some sensors do better in certain environments, I mean, and different environments may have different limitations of what we can use. If we're in, a caustic area of a plant where, everything that's made of metal is rusting away or corroding away, that's going to be a different environment than maybe if we're, outside on a lake or a waterfront where we're not having that type of environment. Or it could be temperature related. It could be, class 1 div 1 because of a lot of airborne dust or fumes. So there are different limitations to sensors based upon the environment that we operate in. But I'm pretty excited because I think this webinar is going to give you a lot of great, useful information. And from here, what we're going to do is we're actually going to take it out to the City of Tulsa on site and learn from Scott, and then we'll be back in the studio to actually have some question and answers. So stick around, but let's head out to Jeremy at the City of Tulsa.
Joined here by Scott. He's one of the pros out here.
Morning.
Thanks for joining us and for letting us come out here and do this stuff. Appreciate it.
Absolutely.
Wastewater treatment is a pretty big deal when it comes to city management, right?
It is.
What happens when the wastewater facility goes down?
Well, we prefer it not go down. We do have fail-safes in place too as well. We do have some retention that we can back up into our sewer systems for probably about an 8 to 9 hour period of time.
Yeah.
Preferably so we can get backup generation for power in the plant too as well, so we can treat. So, but in a perfect world, that's the way we operate.
Probably a good call, right?
Yes.
Yeah, you don't want things backing up into houses and businesses and.
No, absolutely not.
It's like so you guys take PDM or predictive maintenance pretty seriously.
We do.
Okay, so what are some of the tools that you guys use for that?
We're currently using AssetWatch for our predictive maintenance and vibration monitoring.
Yeah.
We started with them approximately 1 year ago. Started on a trial basis for the first 6 months to see exactly what they could produce and what they could, how they could perform in our plant, and been very impressed so far.
You said you started you tried them out at first. Was that like one asset that you guys were going with and then you pushed it out to multiples, or?
No, actually we started out with 50 locations.
Oh, wow.
So 50 contact points. When we do take you out to show you the equipment, you'll see what placement we did have the equipment on. We actually put it on our blowers here, our contact basins, and also 2 of our lift station pumping systems too as well. So.
Are they monitoring both ends of the bearings, like on motors?
We are. We're doing, free in, load in on motor and free in, load in on the blowers too as well. So there's a total of 4 per unit. So on our gearboxes, on our contact basins, we have them on the motors and upper and lower on the gearboxes too as well. And I believe, if I'm not mistaken, there's one on the center to monitor gear mesh too as well.
Now, when it comes to the monitoring itself, it's like these are remote sensors, right?
Yes.
It's like you don't have to go out there and check on them or anything like that. I mean, I'm sure you've got inspections you do just on the general inspections on the equipment, but how are they as far as? Are they staying put well? Are they?
They are. They have a magnetic base. It's actually glued to the unit itself, so they stick very, very, very well. And we've never had an issue specifically with them coming off. We've had one failure, but that was a battery failure, an internal component. But AssetWatch was very good about sending us new ones to put them on as part of our contract.
Okay. Now, for the interpretation of this stuff, because AssetWatch, they're doing vibration, they're doing temperature, right?
Correct.
Do you guys have your own in-house vibration guys?
We do. We have one level 2 certified and one level 1.
Okay.
But at the level that AssetWatch is at, and level 3 and level 4, no, we don't.
Okay.
They having that extra set of eyes to watch our equipment. I believe they do 3-hour increment samplings.
Yeah.
Is definitely very beneficial to us.
So every 3 hours, that's a lot of vibration data coming in.
It is.
I was going to say most places I go to, they'll run a route, max about once a month.
Mm-hmm.
right? And then you kind of just get that one snapshot. But you guys are actually able to see real trends in the data and see if something's progressing that way, aren't you?
We are. We pick up anomalies that do come along. A perfect example, we had an issue with one of our blower bearings. To the human ear, you couldn't hear it, you couldn't see it, you couldn't trend it that way, but they picked up a manufacturer defect on the bearing that was very minute.
Yeah.
And it was developing over about a 2-month period of time, and we ended up shutting it down and actually taking the bearing out, and we found the anomaly too as well, which it caught it in a predictive manner to save us a ton of money. They said the actual savings would have been about a $45,000 savings.
Very nice.
So it was a major money savings. So.
Heck yeah. I was going to say that's one of the big things that a lot of production facilities look at is, the cost of that downtime, right?
Exactly.
Because you guys aren't necessarily producing anything. You're not held to that same, we got to get so many, gadgets off this assembly line, but it's that downtime or it's the cost of replacement parts and the personnel hour it takes to actually do the tear downs, fix things and then reinstall it, right?
Right. Within water and sewer, we're required to have redundancy in our equipment. But on the same token, too, we want the reliability, too, because you go to your secondary and your third position type equipment, and you get to that point, you're basically stuck. You want to make sure you don't get to that point, and having this predictive technology helps us get to that point.
That's awesome. How's it been working with AssetWatch?
Very good, actually. Very easy to work with. Their customer service is great. Their technicians, they're responsive. They actually are on it 24/7.
Yeah.
So they've in the beginning, they even told us, they said, well, if you need help from us in any way, shape, or form, or we see something that's odd or out of the ordinary, we're going to contact you, whether it be in the middle of the night or you need to call us, you can call us. Which there's a lot of companies that don't do that. They're usually subbing it out, but they're not doing that. They're actually performing exactly what they said they're going to do. So
I think that's pretty cool because I know that AssetWatch, I've talked to a few of the guys out there, kind of like you. I knew them when they were Nikola Labs, then made the transition to AssetWatch, and just watching them grow and talking to them over the years, that they actually have dedicated analysts for each client.
They do.
And that's got to be fantastic because it's almost like you have another external team member that's on your reliability team.
And it's comforting to have them. And we're actually going to be using them in our different applications for our water treatment facilities too as well, even in our lift station applications too as well. So in they call it SOM, which is underground.
Yeah.
So yes, we're looking at that aspect too. So.
Now, the sensors that are being used out there, how do you guys receive the information? How do you guys know about what's actually going on?
Via alert through either through their mobile app or through PC. Typically right now it's PC, but we're developing on the other end for mobile app too as well, and I believe they're developing that on their end. If they do not have it already, I believe they do.
Okay.
We're working towards that too, going mobile, so we can see it in real time when we're out there. But if not, it's typically alert on whether it be on your phone or on PC.
Okay. It's like that'll be pretty wild, getting real-time results in the field, like on your phone or tablet or whatever.
Absolutely.
How was this received by the team out here?
The Northside wastewater treatment facility has been very receptive to new technologies. And I will say they've spearheaded this process along with the MRT. When we went down this path for selection, I went over the criteria, what we look for. I believe it was accepted. It was very well accepted here. We see a lot of progressive thinking within the plant.
Yeah.
And within the team, and a lot of them are starting to follow suit with what's been done here, which is nice. And the advantage of having this here is it's a learning tool. It's going to project us into the future. It's going to improve our maintenance processes and our predictive practices.
Yeah.
and it's going to improve our maintenance overall of all of our equipment. So,
all right, what would you think the return on investment has been on this?
So far, it's early,
Right.
but I would say initially it's probably going to take anywhere from maybe 2 to 3 years to see a return. From a dollar standpoint, the bearing that we found paid for its first year of service or more.
That's
or maybe 2 years of service. So that we're actually getting through AssetWatch. So. And as we go with our larger pumping systems, they're large here, but and our blowers too as well. We have 3,000 horsepower pumps at our water treatment facilities, which is going to be beneficial for us to be able to catch issues with them too as well, because it can be very costly when you have failures on those.
Yeah,
So,
blowers aren't cheap.
No pumps, blowers, no, they're not cheap at all. So
that's fantastic. You guys have got a lot of good stuff going on out here. I know that you've been extremely receptive to us coming out here and doing interviews and doing in our own internal training in the facility and stuff like that. We really appreciate it.
absolutely.
Is there any advice that you would give to another facility or another team that's looking into these technologies and what they should be looking for when they're wanting to start making that transition from the reactive stage to being more proactive and getting that predictive maintenance down?
I highly recommend to get on the train now to not only manufacturing facilities which have implemented this type of technology, but municipalities. I know there's some hesitance towards the artificial intelligence type of programs, but honestly, it's one of those things that it's a technology that's going to save you money. It's going to save you time. It's going to save you maintenance time and maintenance work, labor hours too as well, and keep you away from that type of reactive maintenance that you should be avoiding.
Yeah.
It really will. Municipalities primarily, because I work in municipalities, I know how slow they are to turn the corner, and I highly encourage it. It's even been slow to turn the corner within our city.
Yeah.
But now that myself and the rest of the team is pushing this to as well to go more down the predictive path, it's definitely paying dividends. So
Awesome. And any other words of wisdom for folks out there?
no, not at the moment. It just keep an eye on the predictive technologies. Look into the companies, dig into the companies very deeply. Make sure that you know what you're getting into, and know what they provide. Dial it in before you decide you're going to pull the trigger and actually get that technology in.
All right, welcome back to the studio. So we do have Scott Furman here with us. We're going to be answering some questions and answers. And Scott, we really enjoyed what we saw out there in the interview with Jeremy. And I know people have a lot of questions about how you've implemented, how all this goes. And while this webinar has been going on, we've been, receiving questions. So we're actually going to go to our producer here who has selected a few of them. So producer, what do we have?
All right, first question is, what was the most difficult element of the transition to a predictive maintenance focus from a reactive maintenance approach?
All right, so talking about transition, predictive maintenance from reactive maintenance, obviously there's a lot that goes into that. So Scott, what do you think? What has been the most difficult? What are lessons learned?
Lessons learned going from reactive to predictive, I would say buy-in was the biggest factor. We'd already transitioned a little bit more into preventive, and then we were rolling towards predictive and implementing that in a more structured manner. And the acceptance was there, but it was very pessimistic in the beginning.
Sure.
Everybody wondered if the technology was actually going to work.
Yeah.
But after we received a few results, it actually definitely started to
get some buy-in.
Exactly, and some buy-in for it too. So
it's funny because so many people look at the hard skills of things, right? The technical aspect of it. Maybe it's the hardware aspect of it. But that's not typically the hardest part. It's usually the soft skills side of things. It's actually getting the team on board, getting the buy-in. And like you said, usually showcasing a few wins early, that definitely helps out. I think John Maxwell talks about the law of the flywheel, right? Getting people involved and starts to gain momentum. Right. And then it's basically self-perpetuating at that point. So, right. I mean, how did you get some buy-in? I mean, was it all about showcasing wins, or was it just beating the drum and saying, no, we're doing this, it's a good idea?
Well, we primarily went down the path of training and introductory to vibration, and we had several participants from within the city and the plans that we deal with, and a lot of them seeing the writing on the wall of the direction we were going, and then implementation kind of followed that path. So.
Gotcha. And maybe a little tag on there. Were there any pitfalls or anything that, like, if you went back, you'd say, man, I wouldn't do that again, or maybe do it a little bit different?
No, not really. It was actually a pretty smooth transition. They, when AssetWatch came in and did a 6-month trial with us, they took us through it step by step to show what they were going to produce for us and what type of service they were going to provide. And I thought it was very interactive, and they were very thorough how they explained what their process was.
So pretty clear from the get-go.
Yes,
that's a good way to go. All right, another question.
What were the deciding factors to influence you to go with a software as a service solution versus a non-subscription based service?
All right. So what made you select basically a software as a service versus a non-subscription, owning the hardware or anything else?
Well, to be quite honest with you, this type of service or this type of field requires certifications and different levels. There's 4 different levels of vibration reading. And we really did not have the internal qualifications or training in place to be able to succeed. So we went with the path of the service too, as well, to actually bring our staff up to speed, and to also encourage them to go down the path of getting their certifications so they could actually understand what we were doing and the process that we were taking. So
it sounds like it's kind of a parallel type thing, right? We're leaning on an outside source, as basically a resource,
right.
But you're also training up your internal staff to, I guess, make better sense of the data that's being collected. Is that about right?
Absolutely. Exactly.
And then obviously vibration, there's 4 levels. We talk about lubrication, there's many levels to lubrication as well. And certification is so incredibly important, just because it does showcase the credence that you are able to apply what that you've learned something. How many staff are you talking about, getting certified or getting through training? Is it someone at each different facility, or a couple people? Or
we're looking at certifying at each facility, and right at the moment we have 4 at level 1.
Okay.
And we're working on level 2. And actually we have one going in for training next month.
Okay.
Level 2.
Well, very nice. And then as it comes to relying on an outside partner, basically your software as a service there, have you felt like that has helped maybe motivate some of the people to get certified or to understand, what the data is actually saying better?
It has actually. It actually gives them a better understanding of what we're actually doing. What trends we're seeing, what patterns we're seeing within the different levels of readings that we're taking too as well. Because we sample every 3 hours.
Yeah.
So we have that data provided to us through AssetWatch, and they actually show our mechanics and technicians what we're doing and what we're monitoring, so they can actually see the progress in the process.
So every 3 hours, that's 8 times a day, replicated over how many connected pieces of equipment do we?
Around 50.
About 50 and multiple bearings, so multiple readings. So we could drown in this data. So if we didn't have, the ability to lean on someone outside that really knows how to cull through it, I mean, that data is almost wasted at that point.
It is, right. We have certain trigger points in the different oscillations that we're monitoring, and they report those immediately. They're very good at responding to us and letting us know if there's an issue. So
no, that's fantastic. All right, we got another question.
Is it a good idea to combine oil and vibration analysis, and do you have any plans to do so with AssetWatch?
All right. Is there any value to combining oil analysis and vibration data, and do you have any plans to do so? What do you think?
We are seriously considering it. We currently use an outside service right now with a supplier that for our oil products and lubrication products. But we've had some discussions with AssetWatch too as well of combining services. Yes, it's definitely one of those services that would be a great combination between the two as well, so we can see what's going on the oil side as well as what's going on the vibration side of the business.
So what do you think, I'm just curious your thoughts on this. What do you think you would see different between the two, and what do you think you would be able to correlate between the two different technologies?
Well, if you can pick up different contaminants within your oil,
Sure.
And when you do an analysis. And on the vibration side, it would sometimes, if it would probably clarify what readings we're getting from the vibration side. Say if there's a bearing breaking down or a bearing internal race is starting to shed metal internally, and it's giving that metal off and it's actually discharging into your oil product too as well, or your lubrication product. They go hand in hand. You'll be able to see that within the evidence of the oil sample too.
Oh, I agree, and this is oftentimes where there's, spirited debates, it seems like, of which technology is better, which one gives you earlier detection. And I don't think it's necessarily about one being better than the other, right? It's about holistically looking at your assets. So in your mind, what would a good combination of oil analysis and vibration data look like? Is it a seamless thing that you're taking oil analysis data more readily, comparing it with vibration? Is it something that only if you see a fault with one or the other that you compare both of them? What would you think would look best?
I'd lean on the side of fault between one or the other, to where if you see the fault internally from a vibration reading, you do take your oil test or your oil analysis and see what other additional information you can get from that. What does the oil look like? What is it telling us? To as well. It doesn't mean that you shouldn't be sampling on a regular basis on a predictive pattern.
That's right.
The vibration side leans more towards catching it ahead of time, which is another predictive pattern. So they can be used hand in hand, to answer your question.
Yeah,
So,
I think so. And I know sometimes it can be difficult, right? Because oil analysis, it's a bunch of numbers on a page. It doesn't have maybe the amount of information that can jump out at you in real time, like a vibration or an ultrasound or something. And when you look at, what kind of metallurgy do you find in there, sometimes it can be hard to tell. All right, is it an element of the bearing that's going bad? Is it the race of the bearing going bad? Because metallurgy may be very similar. Vibration, it's going to be a lot more clear. But if you back up well ahead of that, and you're taking your oil samples and you're saying, man, it's loaded with dirt or water, well, that's very proactive at that point. Maybe we can take some sort of action to minimize the failure, push it way off before we even see any metal in the oil, before we even see any vibration readings. I've been told by a lot of people that do vibration a lot that a good lubrication program makes your vibration data that much better.
It does.
You agree with that?
I would agree, yeah.
And obviously cleanliness is part of that, using the right lubricant about that, making sure the machine is set up, to exclude contaminants. So I think it all goes hand in hand.
It does. It definitely does. I mean, they're both great predictive tools. They really are. And like I mentioned too, you have to use both to be able to see where you're at. And also it's a cost savings as well too. So
that's it. All right. Next question.
How can organizations break away from the reactive cycle of doom quicker, and does acquiring condition monitoring technology guarantee this to some extent?
Reactive cycle of doom. That's I like it, right?
Right.
So what do you think? What needs to be done to break out of that? And does condition monitoring help with that? How does all this play together?
Well, condition monitoring does play into that. We're going down that path, especially with the vibration services and whatnot, and oil analysis too as well. You break out of that cycle by knowing and being able to predict what's going to happen next.
Right.
You break out of that reactive cycle that keeps you on your toes, constantly fighting fires, to a predictive type of maintenance, to where you're planning your repairs, you're planning your services, you're planning your preventive maintenance services too as well, instead of spending time spinning your wheels.
Yeah.
They're doing reactive maintenance. I hope that makes sense.
It makes sense. If you would paint me a little picture here, if you were to say, all right, your reactive cycle of doom, what would that have looked like before you went on this path, for condition monitoring? I mean, is it maybe it's not necessarily that you're having a rash of failures, it's that they'd creep up on you, or what would that be in your world?
In a reactive world, and I've been in this situation prior to the City of Tulsa. Give you an example. We run some pretty large blowers in our wastewater systems.
Sure.
We have a catastrophic failure on one of our blowers, which is something that that AssetWatch did catch for us and saved us. If we'd have turned the script on that and let that fail catastrophically, we're looking at, number one, cost of the failure. We have redundancy, but if at the time we didn't have the redundancy and that was our only blower, then our process is down. So we have no way to be able to treat wastewater.
So now we're filling up retention ponds or something.
Right, and we're backing up our sewer systems and whatnot. We don't have the parts in stock, which we planned for that already. We didn't have that in stock, so we've got the lead time to get parts in. We have to hire outside contractors to provide aeration for us so that we can process. So there's another cost involved. So it amplifies itself on a very high scale of what we would have to do in order to make our processes work from a reactive state versus being able to predict that issue happening. Yeah. So it's definitely, it's very costly.
I can imagine.
From a part standpoint and from a labor standpoint.
And it sounds like it compounds pretty quickly as well, right? Because now we're down, now there's outside contractors, now there's expedited fees to get parts or whatever. But I think you're hitting on something there, right? It's not about just a technology that brings us out of that. There's also a lot of processes that brings us out of that, because we can have the best technology on the planet to let us know how the machine's doing. But if we don't have the right parts inventory or the right planning and scheduling department, actually doing the right things,
right,
all this has to actually play together very well.
It's a domino effect. It really is. They say when in wastewater, if it fails, it really rolls downhill.
Of course. Okay. And don't chew your fingernails, right?
No, exactly. Don't do that.
All right. We got another question.
So after implementing AssetWatch's solution, who performs the data analysis and makes corrective action suggestions? Are you leaning pretty heavily on AssetWatch's team for data interpretation, or is it more of a collaborative effort between your team and AssetWatch's team?
All right, so it sounds like they want to get into a little bit of the nuts and bolts of how you actually interface, how the whole process kind of works. So if you don't mind, kind of walk us through it.
Absolutely. We work hand in hand with AssetWatch. When we do have issues, they're reported immediately by email, via text, by a phone call. We also get integrated dashboards that actually show us what's happening to as well, and they identify by different alert stages. It's yellow, red. I think the other is orange, if I'm not mistaken. The highest
different severity.
Different severities, right, in code. And they actually will let us know what severity we have. They actually let us know, hey, we believe this needs to be watched. Let's keep an eye on it, or they need to take it to the next level of severity and say, hey, we need to take action with this. We need to shut this piece of equipment down. We have monthly meetings, which, being the coordinator, I sit down with the AssetWatch team and the maintenance supervisor at the plant, and we go over the data too as well, and we see where we're at and where we're trending to as well. Do we need to move to the next step from the watched items, or how do we need to proceed? What did we find?
Right.
So, but we are working together.
Now, is this something that, because I know you've got multiple different facilities or different locations, is there kind of a key person in each location that is that interface? Is it one person holistically for the City of Tulsa, or how do you spread that out amongst staff? It's
one person holistically, and it's the maintenance supervision, first level. And then it's actually transitioned on to the technician too for repairs too as well, to actually verify everything, to see what's happening with the piece of equipment, what type of problems we're having with it, and to do a little bit deeper dive.
Now, piggybacking on a previous question, when you talked about getting folks certified in vibration and looking at different condition monitoring, is the idea that more and more of that decision making and maybe data analysis comes in-house over time?
It will eventually, but that's down the road. That's going to take a little time. Of course, it's a financial thing too as well. We're trying to get people certified and up to speed, and getting them to that level, especially ISO level certifications, it's going to take some time. We definitely will have the continuous service from what I'm understanding and from what we're developing. But yes, the internal education will definitely ramp up.
Well, I think that's fantastic. Obviously, the more they know, I mean, the better it is regardless. Shortens that length of diagnosis, and it shortens that period of kind of uncertainty of what's actually going on inside the machine.
Right. It elevates that understanding too.
I agree. All right, I think we have time for one more question, so let's take the last question here.
How did the appropriate person justify the investment to transition to this predictive maintenance model?
All right, so cost justification. How do you justify, the improvements or at least the initial investment into this type of technology?
Well, we truly vetted different services to find out what direction we wanted to go. As I mentioned before in previous interview, I'm part of a maintenance reliability team that consists of superintendents, maintenance mechanics, maintenance technicians, electricians as well. We fully vetted each system through our team and my director as well, so that they could see what the benefits were, and of course the costs as well too. But the benefits of predictive maintenance and what we could succeed at with predictive maintenance. Right. Justification for cost. As I mentioned a few minutes ago about internal training, it helps us develop our staff to be able to understand what vibration is and what the technology can bring us.
There's an exposure now.
Exactly. And it also shows, which I'll give you a perfect example, the justification within the 6-month trial period. We found a bearing race that was giving us issues.
Okay.
And it was during the trial period that we caught it. It wasn't when we were in full service with AssetWatch. And that was right there. It actually justified going forward with the program. It saved us about $45,000 for the repair.
Yeah.
So of course, money's on everybody's mind. Yeah. We have to save money where we need to, and justifying the repair and the cost of that versus what it did cost us to do, which was around $15,000. It was a far cry from what we would have had to have paid to get this piece of equipment fixed.
And avoiding the disruption that occurs and everything that goes with unplanned machine outage. Exactly.
So the monitoring services showed us what it could provide us. And it also showed us justification of going forward with the process and the predictive maintenance technology. So
I kind of want to back up just a little bit here, because before there was ever a trial, before there was ever, looking at potential technologies out there, there had to be, an inkling of an idea of we need to do something better. We need to move more towards this predictive or real-time monitoring stage. Do you have any insight into, kind of what that catalyst was or what that mindset was to actually start this process?
Yeah, and I don't toot my own horn, but I was the driver in that.
Well, good job.
Yes, I saw the potential, and the rest of the team got on board with it too as well after I provided the documentation and the research behind it to move forward with it. And they got on board with it. I'm a true believer in technology.
Okay.
I'm a true believer in predictive maintenance.
Okay.
And I thought it was a great avenue for us to actually explore and move down. So.
Well, I think that's really good, and unfortunately, that's about all we have time for in terms of questions. I do want to be a good host here. Do you have any final comments or anything else that you want to put out there to everyone joining us on this webinar?
I would encourage everybody to look into predictive technology, especially vibration and any other technology that's coming out. It may seem like it's smoke and mirrors, but it's not. It really is not. A lot of people have a stigma towards artificial intelligence in some ways, but embrace it. Don't reject it, because it's actually going to help you and not hinder you. So I would encourage the predictive path.
I think that's a great message. So for everyone joining us, thank you so much for watching this webinar. If you didn't get your question answered, because I know a lot has come in, don't worry, we will be answering questions. If you don't hear from us during this actual webinar, you'll hear from us afterwards. But we'll have a team that is answering questions as we go. And for those of you that want to know more about Scott and more about the City of Tulsa, check out Noria's Gear Talk podcast. Scott was actually interviewed, one of our earlier episodes, so you can hear more about this transformation. But thank you so much for learning more about predictive technologies, and we'll catch you again on another Noria webinar.